Okay, so this is page 553, section 6 in chapter 5. So I'll go through some of these problems. The first one is number 9, and it has a picture that looks like this. Remember, if you're going to maximize these, what you need to do is you need to find this formula first of all, and you're going to replace the x's and y's with all the vertices of the shape that is shown. Okay, so remember this shape's created with a bunch of constraints and rules. And so since this has 5 vertices, I'm going to have 5 z functions or z equations. But I'm going to replace the x and y each time with the points that correspond to one of those vertices. So that's what I've just done, is written that 5 times. And now what I'm going to do is I'm going to come over here. I'm going to start somewhere and just start plugging those numbers in. So 0, 0, 0, 9, 4, 8, 7, 5, 9, 0. Now I'm going to calculate each of those. 0, 0, well, that's 0. 3 times 0 is 0. 2 times 9 is 18. 0 plus 18 is 18. 3 times 4 is 12. 2 times 8 is 16. 12 plus 16 is 28. 3 times 7 is 21. 2 times 5 is 10. Add those together, I get 31. 3 times 9 is 27. So my maximum value is 28, and it occurs at the point 4, 8. And that's all you have to do on those problems, is find the maximum value and tell me where it occurs. Okay. And hopefully you all looked at that and you're like, are you sure that 28's bigger than 31? Because last I checked it wasn't. So you see that I messed up. So you see the maximum value is 31, not 28, and it occurs at 7, 5. That's a little better. So there's our biggest value, and it occurs at 7, 5. So sorry about that hiccup at the beginning. We'll hopefully do better from here on. So now in the next one, it says maximize. This is number 10. And it has these points, 1, 2, 3, 4, 5 of them. So again, I have z equals 1.8 x plus 2.2 y. So I'm going to have that, and I'm going to replace this with all of those points. This is what I'd really like to see on your test, is you write it out like this, because then I understand, I know that you understand what you're doing. When I just see an answer, I really don't know if you understood correctly. I don't know for sure. So when I see it like this on your test, it makes it so much easier for me to say, hey, they understand what they're doing. They made a mistake like I did on the first one, but they did everything right. They just got in a hurry, whatever it may be. Okay, it helps me to know what's going on inside of your head. So anyways, just a thought for you. So now I'm going to go to my calculator, and I'm going to type this in. See if you'll let me move this. 1.8 parentheses 0 on the first one. I'm going to put double zeros. There's a reason why. I'll show you in a second. 2.2 and 27. Parentheses 27. And it's 59.4. So now the next point is 18 and 27. So I'm going to hit second enter. And where those zeros are, I'm going to go back and hit 18. So that's 91.8. Now it's 27 and 9. Hit second enter. 0, 9. That just saves me from having to hit second delete and insert a space if I have those double. So I know everything has at least two values. Same here, if I put in 09, then that carries that value for me. So that's 68.4. It was 27, so that works. So that's going to be 48.6. And then the favorite one, 0, 0, that's 0. So if I'm maximizing 59, 91, 68, 48, 91 is the biggest value. So the maximum value is 91.8, and that happens at 1827. Okay. All right, next question. Number 12. So you have to do number 11 still, but I just thought I'd work through some of these. It says minimize now. So now we're after the smallest value. So I have 6, and I have 4 vertices. So I'm going to have 4 of these. Okay. One for each vertex. Now you start plugging in the points. 8 and 18, 2 and 14, 18 and 8, 14 and 2. So 6 times 8 plus 9 times 18. And sometimes it's just as fast to type in the numbers as it is to hit the arrow over and all that kind of stuff. So 12, 6 times 2 is 12, plus 9 times 14. So 12 plus 9 times 14 is 138. 6 times 18 and 9 times 8. So 6 times 18 plus 9 times 8, 72, 180. And 6 times 14 plus 9 times 2. 6 times 14 plus 9 times 2. 102. So that is my minimum value. That's the smallest one out of all of these. So 102 is my minimum value, and it happens at 14.2. So I would really write minimum equals 102 occurs at this point, and that would be our solution. All right, number 14. It doesn't have anything on here because it gives you this information. You have to graph your own. So you have to solve for y. So I'm going to minus the 2x from each side. So y is less than negative 2x plus 40. On this one, I'm going to minus the x over. So I have 2y is less than or equal to negative x plus 50. Now I'm going to divide it by 2. So y is less than negative x halves plus 25. So that kind of makes things a little bit more challenging. Counting by 5, or by, this is a 40, this is a 25. So I can't really count by 2s because that'll skip the 25. I don't have enough to count by 1s. I really don't want to count by 4s. If I went 5, 10, 15. So I have 20 squares, so I am just going to count by 2s. Now I'll do the same thing down here. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 22, 24, 26, 28, 30, 32, 34, 36, 40, 42, 44. All right. So now I kind of have my grid set up. I'm ready to graph. X is greater than 0 puts everything over here. Y is greater than 0 puts everything up here. So I'm just looking in this quadrant. So now y is less than negative 2x plus 40. So I start at 40. I go down 2 over 1. So since I'm going down 2 over 1, I'm going to end up at 20. Okay? Oh. And it's less than, so I'm shading in this triangle so far. Now negative x halves plus 25, that's going to be a little harder to draw, but, you know, we do what we can. Dot right here. Now we're going to go down 1 over 2. Down 1 over 2. And continue on with this line. And so it crosses right there. We hope. So now, so this is also less than, so now we're just looking inside of this shape, okay? So the region that we're looking at is just inside of here. So now we need to find all of the vertices for this. So this vertex right here, x is 0, y is 25. This vertex down here is 0, 0. And this vertex, x is 20, y is 0. And now we have this one. That looks like it's on 20. And having a hard time figuring out that one for sure. Don't know why, but it's on 10. So 20 and so x is 10, y is 20. So I have 4 vertexes. So 4 vertices is the correct way. So I'm going to plug those into this z equation. So I have z equals 9.2 times 0 plus 8.1 times 25. And I have 9.2 times 10 plus 8.1 times 20. 9.2 times 20 plus 8.1 times 0. And then, of course, we have our favorite one, 0, 0, which is just 0. So again, I go back to my calculator. (8.1 times 25) is 202.5. 9.2 times 10 plus 8.1 times 20. So just make sure 9.2 times 10, 8.1 times 20. Okay, so that's 254. And the last one we have is 9.2 times 20. And that's 184. The reason I just did 9.2 times 20 is realize this is a 0. So anything times 0 is 0. So all I really need to worry about is that first part. So the maximum value is this one. So my maximum is 254. And it occurs at the point 1020. Okay. So that's that problem. Now the last one that I thought I'd maybe try to help you with is 21. So it says that you're going to build furniture, okay? So you're now a furniture manufacturer making tables. So the cost for materials and labors to build a kitchen table is $240. The profit is $160. The cost to build a dining room table is $320, and the profit is $240. Let X represent the number of kitchen tables. Per month, let Y represent the number of dining room tables per month. Okay. Write an objective function representing the monthly profit for producing and selling X kitchen tables and Y dining room tables. So my profit, we're going to call it Z, is 160 times the number of kitchen tables we sell, and 240 times the number of dining room tables that we sell. So the easy thing would be like, hey, let's just sell straight dining room tables, but maybe they don't sell as many. So anyways, it's going to have a whole bunch of rules now. So we've written our objective function. That was part A. Part B, the manufacturing process is subject to the following constraints. Write a system of inequalities representing the constraints. The number of each type of table cannot be negative. Well, that just means the x has to be greater than 0 and y has to be greater than or equal to 0. Okay. Due to labor and equipment restrictions, the company can build at most 120 kitchen tables. So x cannot be more than 120. The company can build at most 90 dining room tables. So that's y has to be less than 90. The company does not want to exceed a monthly cost of $48,000. Okay, so that's the cost. So that's 240x plus 320y. So we're just talking about cost. We do not want to exceed $48,000. Okay, so that's our constraint. So let's go ahead and solve this one for y so that we have a y equals. So I minus the 240x over, so I have 320y is less than negative 240x plus 48,000. So now what I want to do is divide this by 320. So those zeros disappear. 24 and 32 are each divisible by 8. 24 divided by 8 is 3. 32 divided by 8 is 4. So that's negative 3/4 x. And 48,000 divided by 320. 48,000 divided by 320 is 150. Okay, so I go up to 120 here, 90 here, 150 on this. So I'm going to count, if I count by 10, I need 15 spaces. If I count by fives, I need 30s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 spaces. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I don't have enough, so just count by tens. So this is 100, 120, 140, 150, 160, 170, 180, 190, 200 down here, 20, 40, 60, 80, 120, 140, 160, 180, 200. So realize since this is x, this is my kitchen tables. This is y, so these are my dining room tables. Okay. X is greater than 0 means everything over here. Y is greater than 0 means everything up here, so we're just looking in this first quadrant. X is less than or equal to 120. So 120 is this line. Y is less than or equal to 90 is this line. And since they're both less than, I'm looking in this area inside of here right now. I'm just looking inside this rectangle. And now negative 3/4 x plus 150. So I start up here at 150. I go down 3 over 4. Down 3 over 4. Down 3 over 4. Down 3 over 4. Down 3 and over 4. Okay, and it's less than that, so I'm just looking inside this region right now. So I'm really just looking inside of here. Okay, so now let's find these vertices. So we're counting by tens, that's 100. So this is x is 0, y is 90. Might as well use black so you can see it. 0 and 90. This point, looks like it goes right down to 80. So this is x is 80, y is 90. This point is 120. And right here, so 90, 80, 70, 60, 50, 40, 30, 20, 10. Okay. So x is 120, y is 60. And then down here we have x is 120, y is 0. And of course we have 0, 0, which we're trying to maximize this profit. So we're not going to use 0, 0. That's going to be a minimum. So I'm not even going to worry about that one. So I'm going to have z equals 160 times 0 plus 240 times 90. That's the first vertex. Z equals 160 times 80 plus 240 times 90. Z equals 160 times 120 plus 240 times 60. Z equals 160 times 120 plus 240 times 0. Well, because these two both have the same x values, and this has a y, I know this one's not going to be my maximum, so I'm not even going to worry about that. So 160 times 120. So 160 times 120 plus 240 times 60. So 240 times 60, 33,600. And since this doesn't have an x and these y values are the same, I'm not going to worry about that one either. So 160 times 80 plus 240 times 90. So 34,400. So our maximum profit is right here. Okay. So 80 and 90. So that means we make 80 kitchen tables, 90 dining room tables, and our maximum profit is 34,400 per month. Okay. So that's the last question. So how many kitchen tables? We answered that, 80 and 90. We found the vertices. That was part D. Test the objective function at each vertex. Well, we skipped 3 of them because we knew they wouldn't be the maximum values. So, and there's our maximum profit. So anyways, that's how you do these, by writing out all of the objective functions, the constraints. So doing all of this, we come up with an answer at the end. So hopefully that helps you with those kinds of problems.